โอเคเรียบร้อยเดี๋ยวรอสักแป๊บหนึ่งนะครับกำลังมากันก็มาดูเรื่องการสอบก่อนก็ได้นะครับระหว่างรอเพื่อนนะเดี๋ยวเราจะสอบ midterm กันนะครับในสัปดาห์ช่วง midterm นะครับก็วันที่สอบก็จะเป็นวันวันนี้แบบวันศุกร์นะครับตามเวลาเลยนะครับศุกร์บ่ายนะครับการสอบนะครับจะเป็นสอบบนระบบตัว class marker นะครับเดี๋ยวอาจารย์จะเซตอัพตัวข้อสอบขึ้นมานะฮะแล้วก็เราก็เข้าไปทำกันนะฮะโอเคเนาะนั้นก็จะเป็นที่จะเข้าไปสอบในอาทิตย์หน้านะครับใช่ไหมอาทิตย์หน้าปะไม่ใช่อาทิตย์นู้นนะครับเนื้อหาในการสอบจะเป็นเรื่องอะไรบ้างนะครับก็เป็นตั้งแต่ครั้งแรกนะครับมาจนถึงเรื่องล่าสุดนี่แหละนะครับก็ครั้งนี้อาจารย์คงไม่โหดถึงเหมือนกับครั้งที่แล้วนะเหมือนกับครั้งที่แล้วก็ทดลองทำครั้งแรกมันก็อาจจะมีอะไรที่ต้องนำมาปรับปรุงบ้างนะครับอย่างครั้งที่แล้วเนี่ยที่ตอนวิชา Data Model เนี่ยเราสอบกันเนี่ยก็ต้องทำให้ถูกทุกข้อใช่ไหมถึงจะได้คะแนนแล้วก็มีปัญหาว่าแบบใส่ไม่ครบอะไรอย่างเงี้ยมันก็จะมีปัญหาได้เป็น partial นะก็คราวนี้ถ้าเป็น partial ก็จะให้คะแนนไปตามความเป็น partial นะครับแต่ถ้าเกิดกาผิดข้อหมายถึงว่ากาไปโดน choice ที่มันไม่ได้อย่างนี้ก็จะไม่ได้คะแนนไปนะครับมันทำได้อยู่นะก็ใช้วิธีนั้นนะครับส่วนก็รอคุณนะส่วนการสอบก็จะสอบกันออนไลน์นะครับตามนั้นนะครับเวลาสอบยังต้องเป็นเวลานี้เพราะว่าเพื่อที่จะให้ไม่ชนกับวิชาอื่นนะเพราะไม่งั้นเดี๋ยวเราจะไปชนกับวิชาหลักวิชาอื่นของเรานะครับตามนั้นเนาะเดี๋ยวเราเพื่อนสักแป๊บหนึ่งมิดเทอมก็คิดคะแนนเป็น30%นะครับก็เดี๋ยวยังไงก็ถ้ามีคำถามอะไรเกี่ยวกับมิดเทอมก็เดี๋ยวลองมาถามได้นะครับยังไงก็ถามก่อนหน้าถึงอาทิตย์สอบนะฮะไปดูข้อสอบเก่าก็ได้นะฮะข้อสอบเก่าก็มีอยู่นะที่ในตัวของหอสมุดนะครับแต่มันก็จะไม่เหมือนนะเพราะว่าออนไลน์ปุ๊บมันก็จะเราก็มีโอกาสที่จะได้อ่าอาจจะมีตัวเลขแต่ละคนอาจจะไม่เหมือนกันข้อสอบคล้ายๆกันอะไรอย่างเงี้ยมันก็เป็นไปได้ที่อาจารย์จะออกไปโอเคครับงั้นเดี๋ยวตอนนี้ก็มีมา19 คนแล้วนะฮะเดี๋ยวเราคงเริ่มกันเลยนะครับ ก็วันนี้นะครับจะเป็นครั้งแรกที่เราจะเข้ามาดูเนื้อหาในส่วนของเรื่อง Big Data นะครับในเรื่องของ Hadoop Big Data นะมีคำถามเข้ามาอ๋อเอาใหม่ลืมโอเค TA เตือนว่า class inter sorry I I see well probably because I teach too many classes and yeah mistake were made right. So what I said earlier was about the midterm examination. The midterm examination will be we will still use class marker to do the midterm examination, and it will be multiple choice as last time. But like I said earlier, that this time it will be less strict comparing to the last time because last time we in the data model class when you made mistake in terms of the choice, say if you chose something like partial correct answer, you not get scored at all. But let's say this time that will be still allowed, but except in the case that you made the mistake choosing the wrong choice, and that is not acceptable. So basically, something like false positive is not okay. Otherwise, it would encourage you to kind of choosing every choice to get at least the score of to get the score, right? So that's it. You need to, in the case of choosing multiple correct answer, you have to choose the correct one or close to the correct one. That's the case. All right. For today, we will take a look at the concept of Hadoop distributed file system and the environment in the big data system. So learning today will allow you to understand why do we need to have Hadoop in order to store the data in why do we need Hadoop to store big data, to store data that in a large size and perform processing of the data when the data is large, right? So we will take a look at the concept today. And also we will have a lab which very simple this time. That is, you need to just copy file and do something very simple to learn how to use HDFS, Hadoop Distributed File System. And yeah, I will talk about that, and also the demonstration of how the VM that he has prepared work. Usually, in the past years, we would ask students to install your own HDFS using the Apache version. But seems like that would be a lot of hurdle due to certain limitations in, I would say different platform would generate different bugs, different errors. And it will be difficult to carry on the class when you have problem like that. So let's say for this time, we prepare VM for you, and you can use this virtual machine by running it on the VMware software. And then you can access the service on the browser, right? And yeah, on the browser and on the secure shell channel. All right, so let's take a look at what exactly is big data, right? So the terms big data and Hadoop is quite interchangeable. That is, when you talk about big data systems, the open source framework for the big data system is named Hadoop. And this is the Apache open source platform that allow you to store data that is larger than just when you have one computer. How does it work? Right? It works by having multiple computers to collaborate, right? To help storing part of the data. Think about it as a team working. When you have people working as team, you can distribute or share the tasks so that multiple peoples would work at the same time, and that would make your task finish faster, right? So that's the idea of it, right? And it allows the system in the distributed manner to work together that allow you to store and processing of the data in the large size effectively and efficiently. In that case, it means that you need to have a cluster or a number of computers that are connected to one another. And Hadoop framework is also allow you to write a simple program and to interact with it. It means that you can write the simple Python, just like what we learned in the early of the class, and then interact with the Hadoop system, okay? The name Hadoop here, this elephant is actually from the toy, the stuffed animal of the Hadoop developers, right? So he named the software Hadoop based on his daughter stuffed animal, his daughter toys. This Hadoop system is actually originated from the Google distribution of the technologies. Google, I think since about the end of 90s, has become one of the promising company in search engine business. And they also released a lot of technology that they invented and used with the search engine in order for other people to make use of the system. They actually, they did not release it in the full forms of that the company developed, but they released the publications or the explanation of how those systems work, the system like Google File System and the MapReduce which is the way that they write a program on the Google file system. And these concepts has become the original idea of the Hadoop project on the Apache project timeline, right? So after that, well, with multiple release of the concepts, this has become like foundations of today Apache movement in big data. Not just what's shown here, but there are also others like the idea of search engine that used in Google has been developed to Apache Solr, and now has become one of the main search engine system used in big data environment. But what exactly is Hadoop? What exactly is the big data system? You can think of the big data system as a cluster of computer. You need to have one computer. Let's think of this one block as one computer. And this computer has to connect to other computers. There will be multiple computers connecting to one another. So how do we connect them, right? How do we connect them together? You will learn that later in your class that you can connect computers together by forming it into a network, right? Connecting them to the switch, to the network switch, and then it will allow the computer to send and receive packet of data from one computer to another computers. But you probably have been familiar with this type of idea already, because right now, even when we are learning today using Zoom, you are connected to the network, right? How did you connect your computer to the network? For many of you, you may have connected that through the wireless channel, right? From our computer here to like the wireless channel, to the wireless router. And from that wireless router, it has the line, the landline that will connect to the switch that connect them together, right? So for the Hadoop to work, for the big data to work, you need to have multiple servers that connect to one another to a certain network level here, so that it can communicate with one another. When the client coming in, the client might assign the task like storing this large amount of data, or please retrieve this data for it. There are multiple roles that the big data system has to assign. We will take a look at that later. So what I want you to understand, or what I want you to get from this picture, is just that for a big data system, you just need to have multiple computers. These multiple computers would have different or separated disks, right? These are very important. To create a big data system, you need to have a separate system. You cannot just have one system and have multiple virtual machines. That would work in terms of creating a system, but it would defeat the purpose of having data distribute and work separately. So you need to have multiple computers with separate resources, separate disk, separate RAM, separate memory, and have different roles. All right. And they have to connect to one another, right? Working as a cluster. Okay. So this is when people talk about big data, this is actually the big data that they talk about. A cluster of computer that allow you to store data in a large size. Okay. Any question first from this figure? You can create big data from, say, PC. You can go to buy your PC, like maybe 3 or 5 of them, and then connect them together through network switch, right? Network switch price, very like gigabit switch, cost you about the 1,000 range, right? A cheap one. Just connect them together, and then you get the cluster. Then you can install the software. Usually this will be Linux, right? You can install the Linux operating system, and then you can later install the software that allow you to configure the node, that allow you to connect them together and let them work as a cluster. Okay, any question from this figure? So how does this how does this differ from when you work with, let's say, your own computer? Can anyone help me here? How does this types of work differs when you work with your own computer, your own PC? Any answer here? Help me. What is the difference? Yeah, one coming in is cheaper. Well, I'm talking about comparing this framework to the case that you work on your own PC. You work on your own PC, meaning that you have motherboard, right, and CPU, and you have, right, in your computer, you would have something like this. Let me draw it, right? You would have motherboard, the main board, the CPU, and this is hard disk. Say connect to the SATA power supply, connect to the main board, have it connect to hard disk, and that would be the bus, connect to RAM. This would be a chipset controlling the communication between this I/O and the RAM, and there should be certain connection to the CPU. So can you make comparison between the way the usual PC work and what we have here? Do you see similarity or do you see any difference? How does this similar to, how does this design would be analogous to the way PC work? Like how, and when you compare them, what are the similarities? Two-way modularity. Modularity in what respects? Come on. Different parts do different things. That include human being. Different organs do different things. Come on, compare the way PC work, right? That you learn in your computer workshop. In I think you have learned that this, or may have seen that this in computer architecture, but I don't know if you learned it already in this semester or not. And the OS as well, right? Or you may have already know that when you go to the store and then buy all these things, they must have been connected together. But you must know, right, that there are ways that computers work, like CPU would do scheduling and processing, RAM would store data temporarily, hard disk, either SSD or the hard disk would kind of store the data even when you close the computer by writing things into the magnetic module for the rotating one. For the SSD would store into the NAND that are allowing you to store data in the chip. How about this? How does this? What is the similarity between the way that you see this and the way that you see in the PC that it works? Okay, I will write first here. You have the VGA connect to the monitor. Which part of PC that is the most similar to what you see here? Which part of the PC that you think is the most similar to the way that this works? Which part? Motherboard? Which part of motherboard? CPU? CPU performs scheduling, so it would be no. It would be no. Which part? Which part? We are talking about Hadoop distributed file system, all right? And the Hadoop distributed file system needs systems that are connected in this way to work. So, well, it is file system. Where do file system work on? On which device that you need to have file system? Which device? I don't know if you have heard this term. What is this? Which RAID should I use as example? RAID 1 is mirroring, right? Better, do you know this? RAID 5? What is RAID? What is RAID 5? Did you, I'm not sure if you have taken the computer architecture or operating system courses yet. Have you? Or is it in the third year, second semester, something like that? Well, but if you learn, if you, well, never mind. Any input here? Do you know RAID 5? RAID. No. What is RAID 5? RAID 5 is when you have multiple hard disks. Well, let me put it this way. Suppose you have 3 hard disks. When you have multiple hard disks, you can configure hard disks to work as JBOD. JBOD means this is just a bunch of disks. Or you can just a bunch of disks mean that you can have this drive as the C drive, the D drive, the E drive. Right? You can configure the disk to work as RAID. Right? If I remember correctly, there should be a RAID processor here, and then you can connect it as RAID, and there will be the number that denote the meaning of this RAID. RAID 0 means that every file coming in, it needs to be partitioned into a small chunk. This small chunk will be distributed into multiple disks. So this will increase the efficiencies of reading and writing. This is called RAID 0. There is another way to configure the RAID. It's called RAID 1. Let's say we have 3 disks. And then you can configure the storage to be RAID 1. RAID 1 is, it means that suppose you have a file come in, say, I'll just split it to be, so that it can be written easier. Let's say this model will be stored in this, and it also, the copy will be stored in all of the drive. This is called RAID 1. RAID 0 is good for performance, RAID 1 is good for reliability. Okay, RAID 5 would perform something like RAID 0, but it would have multiple, let's say it would have multiple versions of the first block storing in a different one as well. So this is RAID 5. It's kind of a mixture between RAID 0 and RAID 1 to allow so that when you have one disk, RAID 0, the problem with the RAID 0 is that if your disk is down, it means that your computer would not work, right? Your computer would be down as well. The problem with RAID 0, the problem with that's the problem with RAID 1. For RAID 0, it's quite robust. That is, if your disk is down or if you have bad sector in this one, it doesn't matter because you still have other disks storing the same things. So this will be quite reliable. The downside of RAID 1 is that you need to invest into this purchase a lot because you need to have multiple disks. This is RAID 1, right? RAID 5 would be a type of compromise between RAID 0 and RAID 1 so that you can have better performance and better reliability, but not as good as both, but better than having both. That would allow you to, that would kind of having the downside in both cases. All right, so this is RAID 5. RAID 5, you would have multiple disks, but it would have, well, I should write in separate way, right? So in RAID 5, say you have 3 disks. RAID 5 work like HDFS here, I think. It might be something, it might be different in the way that it need to have like name node and author node. But for RAID 5, say if you have this block can be stored on the first and the second, depending on the replication factor of the RAID 5. And the other block as well, like this block, it can store on this one and this one. And say if if this fail, you still have the same copy on the other disk. So it will be, the system will be able to recover. And since they are distributed, the system could read the file quite quickly. And this is RAID 5. Right? RAID is usually used not just in your computer, but in something like the NAS as well. The network attaches storage. Do you know the NAS? The NAS storage, which you can actually go to, say, the chip hardware house or auto shop and buy NAS and plug it into your home. And then you have a server, a storage server that you can store file in. And it will ask you to configure whether you want your disk to be RAID 0, RAID 1, or RAID 5, or JBOD, or in all of this, right? So these are configuration that you can configure your computer to. I would say that this knowledge actually, I learned this knowledge, right? I learned this knowledge quite a long time ago. And I would say that most of these technologies do not really require you to attend the class to understand the concept, all right? I would suggest that as computer engineers, you should expand your knowledge, right? And try to gain more knowledge about computer platform and systems. This will be benefiting later, even though you are not working with the hardware, because many of the concepts that you see in computer engineering are kind of redundant and copy and also inspired by the other concept as well. As I'm talking here, the concepts like MapReduce, the concepts like Hadoop here is actually a borrowed concept from RAID, right? From the way that you can store data in multiple disks, and from that you can by understanding that you see the similarity, and that would allow you to understand the concept easier. But in any case, you can see that the way that big data work is very similar to the way that when you buy, let's say, buy a computer, and then you buy let's say five hard disks, whatever you want to use that for, 5 hard disks, and you want it to work together as just one disk, not just 5 disks. You want to merge them together to, let's say, having a better storage, having a better performance, having a better reliability. You can use RAID to configure that. Right? And this is quite old concept. I would say that like 30 years, 20 years ago, this concept. For the big data system, it also works in the same way. That is, if you want to store the data that is large, you need to have multiple physical nodes. Each of these nodes can store the data separately, and it can also run the program separately, so that you can just connect to the cluster, and then you work on it like it have just one unit of cluster, and then you kind of interact with the cluster instead of separate node. This is actually a new way to think in computing. Back then, 10 years ago, if you want to store a large data in multiple computers and write a program onto them, you need to write a program in the parallel manner or distributed programming manner by using something like the MPI framework. That is, you need to kind of specify the IP and everything, and then write the program in control everything, right? But instead of that, nowadays, when you want to work with large data, you don't need to write a program in an MPI way to let them to be parallel. You just need to have multiple computers so that you can distribute the data beforehand to multiple computers. And then you can write a program just once and submit to the cluster and let it manage the working inside by itself. Right? So this kind of revolutionized the way that we need to write a program. So this is the concept of Hadoop, right? This is the concept of the big data that allow us to store, access, and analyze the data that is large efficiently. So how do we do that, right? As I said, this is similar to the concept of RAID. In order to reduce the read and write time, right, how do you think the system would do? The idea here on the Hadoop platform is that it would split the data file that is large to be the multiple chunk. In this multiple chunk, each chunk, let's say this chunk would be distributed to, would be distributed in replication, depending on the replication factor. Say we can set it to 3. 3 means that the red chunk here will be distributed 3 times to 3 computers, so that when you want to retrieve it, you can retrieve it from any of these 3 computers. Or when one computer is down, it would still be there in the other computers, right? So this is the concept of big data that allow you to do things in parallel by splitting the data into a smaller file size, and then split them, store them as a chunk on multiple computers. Hadoop architecture right now is at version 3, right? But well, we take a look at that. So the architecture of Hadoop would look like this one. You need to have the blue here. You can think of this blue as a server or a computer. You have multiple computers. DN stands for data node. And you have multiple data nodes. And let's say data node and task tracker and the TT to track the task inside here. And each of these is a computer on its own. Each of these has to be connected to its own switch, including the name node here. So you have multiple computers connecting to switch, and the switch would connect to auto switch. Why do you think we need to do this? Why? Why do we need to connect to switch to a switch? Can anyone help me here? Why connecting switch to a switch? Why? I'm waiting. This time I'm not going to talk further until you answer this correctly. Why do you think? Just give your own idea. Why do we need to connect them? To link what? Why do we need to connect them together? The two switch one will come later, all right? But let's say why connecting switch on the rack with switch outside? Well, yeah, Gao, right? Has already answered to links that you need to link them together so that they can communicate with one another. And Joey has already answered what Shane has asked. You need a second switch for redundancy, so that if one switch fail, another still work. So why do we want to have redundancy, right? The reason is that when you set up a system like this, it's not cheap. It's very expensive, quite expensive. What is the scale of the expensiveness? So even though the system requires you to you can have like a PC cost about 20K and then connect them together. But usually in the enterprise level, they would purchase like each node here might cost about 500,000 for a medium range piece, for a medium range server, and then they would have multiple nodes. One time that I worked together with a company, and we set up the big data systems for one of the organization, the MEA, Metropolitan Authority, Electricity Authorities. The cost of hardware for that is at the range of, I say, 20 millions. And that is not overpriced. This is the normal price, because for each of these, let's say for the name node, you need to have two name nodes. You need to have two servers to work as name node. You need to have multiple medium range server that are connected to one another. You need to have gigabit and 10 gigabit switch that connect to one another. And then you need to have the software installed. So if you creating the large stack or large size of the big data system, that could cost to something like a billion, right, or 100 millions baht in terms of the hardware alone. But many of the company would still invest into this because by storing a larger size of data, they are actually able to do more things, right? They can write the machine learning, they can store data and make use of those data. And they have to pay anyway to have something like a data warehousing system that give them report, and it costs almost the same, right? So that's the thing. That means this would allow them to do a lot better in terms of doing data analytics and business intelligence. All right, so let's take a look at each of the roles here. we have the name node here. The role of the name node is to store the metadata. You think of the name node, if you compare it to PC, I like to compare it to the way that the usual PC work. If you compare the name node to the PC, it will be something that store metadata of the file. It will store the directory structure. It will store the directory structure of the file system. Right? So this server will be very critical. If it is broken, then if it is down, then it means that the whole cluster could be down. That's why usually there will be a redundancy of this name node, so that if this is down, the cluster is still usable. You cannot do it like if it's down and you replace another computer in, because the disk or the data that is stored in this name node will be critical. It will store which file are stored in which computers. If this is lost, then it means that all the data in the data node would be useless, because you wouldn't know how to link them together, right? So this is very important. The name node is also storing the log file of the transaction that occurring. This allows the rollback, what should I call it? The rollback features that it allows you to kind of, if there's a problem, you can roll back the operation. And lastly, it also handle the replica block creation, right? And you can specify how many replica, and then the name node also handle the instruction sending to data node to make copies of the blocks. For example, if node number 7 is down, and the name node know that node number 7 is down, it already has a list of packet or a list of blocks stored in node number 7. It would need to instruct other nodes that have the following list to make replication of the thing inside. So this would make the system very automatic in terms of redundancy, in terms of the reliability. You'll see that in the later slide. The second role is the data node here, the data node. Or if I come back to here, the name node here, data node are the slave node here. The data node would store the actual data block. And this data node can actually be run on different type of file system, but usually it would be the Linux file system. So this data node has to also notify what block it has, and the name node replicate blocks and store in the data node. Usually it would replicate the blocks. 2x means that 2 blocks would be stored in the same rack, 1 block stored elsewhere. By the way, do you know what rack is before going further? Raise your hand if you do not know what rack is, or click yes or no. Okay. All right. Rack. Let me find the rack and show that to you. I will show you the picture of server rack. Here. These are the server inside the rack. So the rack are actually just a physical cabinet that you store server in. Usually there would be other like accommodating devices stored in the kept in the rack, like power supply, fan, and UPS and others, right? So these are the rack. You probably have seen it in movie, in others things, right? But yeah. Yeah, these are the server rack. Something like this one. These are the server rack. Right. You can store your computer, right? If you have the tower, compute tower means the vertical here, your own computer, you can put it sideways and store it to rack. But usually there will be rack server that looks like this. For example, for the HP DL360, right? This is the server rack. It will be in this format, and then you can just store it in one unit into the rack. So I suppose you see, you now see what the rack is. Right? So that means why storing 2 blocks in the local rack? Why is that the case? Why do you think the name node would replicate 2 blocks in the computers in the same rack? There must be some reason. What is that reason? Think. Yeah, I'm waiting for the answer. Why? If you do not know, I suggest just make a guess. Think about it. Why do we need the blocks? Right, we have 3 blocks. 2 of them should go to the local rack, 1 to auto rack, another rack. Why is that the case? TikTok. No, not the correctness. The other things, something related to data, safety. While storing the same line, safety is more safe. It's safer than storing on the separate rack. No, preventing data missing. No. Suppose that you are a photographer and well, you take photograph you are a professional photographer. You take a photograph and then you would copy the photo from your camera to your computer, right? But and then you would just if the computer one of the computer in the local, well, that example is not good, but never mind. You can copy it to backup, right, on another one, and you can distribute another one to, say, the cloud, right? That the reason might be the backup, the safety that you mentioned, but there is actually another reason, right, that you kind of keep it close to your hand. Suppose that one day the customer asks, where is their data? And you're trying now to get that data out. Which point that you would look for first? The cloud, the backup, or your own computer first? Maybe your own computer, right? If your own computer is broken, or somehow is processing something that is, like, say you are encoding video right now, is busy. How do you get your copy of photograph then? You will get it from a backup, right? Maybe hook that backup to another PC. That is the reason. Right? The reason that kind of the 2 blocks should need to be in the local rack for the efficiency purpose. Because when you kind of trying to retrieve the data. If one computer is busy, you can use another one in the same rack to use the data chunk, and the overhead of obtaining the data would not be significant in that case. Comparing to you need to retrieve it from elsewhere, that would be more significant. Okay. Right. Now, the framework that allows us to do this is Hadoop. Hadoop 1 is out since, I would say, 2012. Right now, it's already 2020, and it's already at Hadoop number 3, Hadoop version 3. What we learn in this class would be like the foundation up to Hadoop number 3, but many of the components are the same, like HDFS has been used since Hadoop 1.0, but it's actually has been one of the component even in Hadoop 3.0, this one. So we'll take a look at the concept here. This time for this lecture, we'll look at this data storage, HDFS. Next time, we'll take a look at MapReduce, how does it work? And after the midterm, Ajahn Rashwit will be the main instructor, and then he will teach you about how to use Scoop, Hive, Flume, and other Scoop, Hive, Flume here, HBase, so Keeper, and the deployment and management service. So there will be multiple software. So each of these are actually multiple software that do different things on the big data systems, right? So if you take a look at your course syllabus, you will see that there will be multiple things that we will learn here. You have already seen how the BI applications work in Tableau, right? And so here is like the whole stack of Hadoop version 1.0. You can see that in the version 1.0, the main way to do the data processing would be to write a program in the MapReduce way, or use the data access framework provided, like using Hive that allow you to write the SQL, SQL query to the database like environment. Right? So these are the way that you can access the data. Now let's see how the HDFS work. In the HDFS, you can think of the system as having the master node and the worker node, or the slave node. The master node here is the name node. Okay, so this name node would control, would store the data. Let me close this first. Right, it would store the file system namespace. This means that it will store which block content would be stored which computer, and it would also store the block mapping, right? That contain the number of blocks and on which computer it is stored. The management, like the log, and then the other operation as well, like the permission of file. Data node, these are the nodes that store the block data, and it also perform block operation like copying and performing operation with the block. And lastly, the secondary name node here is another name node that need to store everything that are inside the name node, including so up to a certain checkpoint, so that if the name node is down, the secondary name node can be brought up to be the master node instead, to be the name node instead. Okay, in the multi-rack cluster, you would have multiple racks connecting to one another, right? Connecting through a switch. In this architecture, suppose that one node is down, right? What would happen? Right, name node would know. Once the name node know that this node is down, it would know all the blocks that it need to replicate, because the name node would store the mapping, right? That which blocks on this file that they are stored in which computers. So in the reverse manner, it would know that this computer would store which block. So once it knows that this node is down, it can instruct the author to replicate the lost node on the other node, right? So this would create a type of reliable storage. That is, if one computer is down, you still have other computers that would still be working. If the whole rack is down, say if the system knows the topology of the cluster and it also has the record, it can also instruct other name node or other node to replicate the block. So it has certain awareness of the rack. The problem would occur if the name node is down, and that would create a problem, because if it is down, then it cannot replicate itself. You need to have it is a single point failure. You need to have a secondary name node to act as the name node after this. For the network performance, the speed of read and write, the read and write speed inside the name node would be faster than read and write speed across the name node. That means that the connection between the node inside should be in a gigabit manner, and for the node to node here, it actually need to be larger. This switch to switch need to be something like 10 gigabit in order to make the system more efficient. Because let's say one line here might need to accommodate a lot of communication between nodes. Now let's see inside of the name node when it stores the data. Let's say we have 3 data nodes, and the name node might store the file system in this form, that you have file number 1. This file, usually the number of replication factor here would be a bit the constant value that we would use, say 3 or 2 or 4 or 5, depending on how reliable you want the storage to be and how much storage that you want. Because if you specify this to be too many blocks to replicate, to the number of replication factor is too large, then it means that each block has to replicate with a lot of redundant, and that is actually a problem in itself, because you would waste storage space. So this work like this. You have file name, let's say file 1. File 1 has replication factor of 3. It means that each block in the file 1 will need to be replicated 3 times. So if the file can be separated into 3 blocks, block 1, block 2, and block 3, how do we separate this data into 3 blocks? Just take the data and then let's say separate each when the data is larger than 64 megabyte, then you have 1 block. So if your data is say 200 megabyte, if your data is 200 megabyte, and store it in row wise, so it would be something like this. If we use 64 64 megabyte to be the block size, you would have the first part. This is 64. The second part, the third part. You would have 4 blocks. And the last part, 64. In Hadoop one, this is usually the case that you need to have the block with this size. But in the latter version, it has been fine-tuned so that you can have the block that is that is like up to 64, but it can be less than 64. But well, let's leave that to that. For now, when you have a file that is larger than 200 megabyte, you can usually HDFS would split the file into blocks. Each block will be replicated according to the replication factor. Here, it will be replicated according to this one. The same goes for the other as well. File 2, replication factor of 2. File 3, replication factor of 1 means no replication. So when it's stored in the data node, the file 1, each block in the file 1, block 1, 2, and 3 would need to be replicated 3 times. So that's why you see 1, 2, and 3 on every computer here. While file 2 has replication factor of 2. This is 4, 5, and 6. And you can see that you have 4 here and 4 there, 5 here and 5 on this computer, and 6 here and 6 on this computer, right? So it requires to have 2 replication in all of the data nodes that we have. For file 3, it has 1 replication factor, meaning that 7 and 8 should have like 1, right, for each of the block. This is how HDFS store data, right? Any questions about this before we proceed further? Right, then let's go. Okay, so for inside here, the name node and the secondary name node would check with one another, so that secondary name node would mirror the file system image and edit log of the file, and then keep it as the record here. And it also need to keep the name node metadata, backup node metadata, do the housekeeping by maybe detecting things that happen in edit log and alters, so that it can like work as the backup node if things happen. But you can also configure it to do something of the housekeeping mechanisms. The housekeeping mechanism is like cleaning things, storing things, delegate the backup, and other tasks that require to make a system work regularly, right? And the name node would get reports from data node on the health, and it can reply to data nodes on the control information that what need to be done. Let's say if one node is down, you will know that the name node would know, and then it can instruct other nodes to make copies. So why do we need to divide the data into blocks instead of storing things as files? The reason is that we need to store it as block because we need the file so that the file can be larger than a single disk. You can store a file in the size of terabyte to the disk that is lower than, has a size or the remaining size less than a terabyte. And the block is fixed, so it is easy to manipulate, to copy. It is easy to replicate there. So HDFS block is default by 64 megabytes, but I would say this number can be changed depending on the distribution, depending on the specification. But why is it much larger than usually file system? But you know that in your computer, especially if you use, let's say if you use Windows, your computer will become slow when you use it for a long time. Well, but that is only when you use it with the rotating disk. In the rotating disk back then, not the SSD, the data block would be, the location of data block is really important because if it is a fragment spreading through our computer, it will be hard to retrieve the data out. That's why you need to do the defragmentation. I'm not sure if your generation know about this. Do you know defrag? Have you done it before? Defragment. Usually file system on your computer would be, when you see that your file on your computer is just one file. But when the data is stored in the computer, it's actually not in that case. Your computer would split, the operating system would split the data into a smaller block. That is the file system block. And this is very small block, say 64K, 32K, or even smaller than that in the byte format back then, right? But the block is much smaller than 64 megabyte here. Why is that? Right, there must be a reason. One of the reasons is to minimize the overhead. Right, try to minimize the overhead that this seeks time. So if you store data in chunk, and when you read the data, you can read this large size of data altogether. So it kind of storing the large size of data on the file system. But imagine actually the file system would split that out anyway, right? But they will be close to one another on the file system. Right? So now there are a lot of logical layer here. You have hard disk, HDD. Then on top of the HDD, you would have the FS. I would say the local FS. Local FS. And on top of that, you now have the HDFS, which is actually not working alone because the HDFS would need to kind of merging with another computer. It cannot work alone, right? It has to have multiple computers so that it is kind of a stack on top of the local file system. So what does it mean by seek time? Now I need to answer you. And do you know what is seek time? When I teach this to, let's say, company outside, I suppose they should know. Now I'm not really sure. Do you know what the seek time is? What is the seek time? Let me ask you this, because I don't want to go to your curriculum and try to find on which year you learn operating system. Have you learned the operating system course yet? Is it in the second year? Or computer architecture? Like these two, I think it should be operating system about this one. On which year, on which semester that you learn operating system? One answer. This semester, right now. All right. Yeah. Do you know what is the seek time? This seek time, right? I would say emphasize on this seek time. What is it? When you buy your hard disk, yeah, the time to get to data in hard drive, right? Yeah, so you can put it simply like that. So this would be the time that you find. It's called seek because you need to seek out the data chunk. If your data are separated, it will be hard to seek the data, right? Seek means to search, right? So seek time is the time that you kind of get into the data, get into the whole file. So if the seek time is 10 milliseconds and you get the file transfer rate of 100 megabytes per sec, and the overhead is the seek time divided block transfer is 1%. So what should be the appropriate block size? Seek time is 1%. Overhead is 1%. The overhead is the seek time and block transfer. We have the file transfer is 100 megabytes per sec. So if we have like a block of the transfer is 100 megabytes, then HDFS block should be larger. Right? It should be larger than this. Otherwise, you would kind of losing overhead more than the time to transfer the file. This is like, so do you know why is that the case? Why say if you have the transfer rate of 100 megabytes per second, then you have the seek time of 10 milliseconds and overhead is 1%. Why we need to have the HDFS block size larger than the estimated here. Okay, no mind. So it is to make the transfer, right? The transfer more efficient than the overhead. You can calculate this afterward. Let's try to that. Let's do that. So let's see how the HDFS read is performed. Then we will take a short break here. I need to go somewhere first. We have multiple nodes that work in different way, right? Usually first the client would, the client would want to read the file from the cluster. So the client would connect to the name node. Once the client connect to the name node would tell the client on the data blocks that it needs to read. Then the client can go and then read the data directly from the data node. That's it. Right? So this works like BitTorrent. Right? I don't know if you know about BitTorrent. Well, you need to kind of store the data on multiple computers, right? And then you can go and read the data from the author, right, through the BitTorrent channel by looking at the torrent tracker and then get the list of the computer that contain those data, and then you can read it. And then it allows us to transfer file through the network very efficiently. If one node is down, you will know where to read next, right? So let's take a break first. I'll come back in say 30 minutes. We will start on 3 p.m. Okay. All right, I'm back. Let me explain this again. Okay, so since why is it 100 megabyte? You may wonder. Okay, how does this come by? Let's take a look, right? Because there are multiple things in this example that I suppose because you have not you need to kind of understand the concept of, well, it's just actually just a two formula that you may not be familiar with. The first one is overhead. What is overhead? Right? Overhead means overhead is something that you have to pay, right? You have to pay besides the actual operation. So having overhead of 1% means that you need to have like the division between the seek time, the proportion between seek time and the block transfer time, okay? The transfer of the whole block to be 1%. Okay, so let's say this is 0.01. This would equal to 6 times divided by block transfer time. So this would equal, we know that the seek time here is 10 milliseconds. In terms of second, this would be 0.01. Okay, so that means you need to have the block transfer time equals 0.01 divided by 0.01, and this equals 1. This is the block transfer time, the transfer time of the whole block of data that you have. Okay, I should write like this: the whole block of data that you have, the transfer time of the whole block. This should equal 1, and the block transfer time is actually equal, because you want to transfer the whole block, right? The whole block. This would equal the block size, BS, divided by the transfer rate, TR. And this equals the block size divided by 100. So in the end, the block size should equal 100. But to make things simpler for computer because it stores data in binary, right? And you know that we use something like the base 2 for the data size. Instead of specify the block size of 100, we specify the block size to be more than 100, which is 128. And this would be the size that is the most optimal for the case that you have like 1% overhead. Okay, so this is how the number here are calculated, right? It is calculated from we'll say the network requirement. So you need to have at least, you need to know the overhead that you expect. You need to know the file transfer rate of the system. You need to know the seek time of the disk, and then you can calculate the size of the block that are suitable. Okay, now let's move on. So why does TDS choose this design to read? So one of the way, why not connecting to the name node? Why do we need to read directly in this way? The reason is because we want to prevent bottleneck, right? You want to prevent the traffic jam in reading the file. And this allows HDFS to scale to the large number of concurrent clients, meaning that if you have a lot of data nodes, you can have multiple clients come in at the same time to read different chunk of data. And it would allow you to spread the data traffic across the cluster. That means the more computer you have, the better the performance of the system. Okay, so if you have multiple, because you already see that there will be multiple replica, multiple replicate of the block on different computer. How does Nano decide which replica that client should go to read? Right, there are certain criteria to go to, right? Like the name node need to have the rack awareness on which block stalling, which it should know which one is the different rack, which one is the same rack, and there will be the criteria about bandwidth here that will help name node decide which node that the data should be read from, right? This measurement of bandwidth, right, is quite complex. So there is a simple idea to do that. So the basic idea that the data in the same node, this would be having more bandwidth if you kind of want to read the data and then perform processing of the data file. If you want to read the data that are not in the same node, you should read from the one that is in the same rack. And then you can go to read the one that is in the same different rack, but in the same data center, in the same cluster. And then you can read it from different data center instead. Do you know what data center is? Let me put it right this picture for you guys. So you have the rack. This rack contains multiple computer. You can have multiple rack to form a data center. Data center. This data center can connect to other data center. Something like that. And then it can kind of spread the packet, spread the files onto different cluster entirely. So it depends on which file will be used at which location, and the spread will be different there. But this is the network topology, and the bandwidth will become less once you kind of go farther away from the node that you request the data. So how does it work to get for the name node to decide which one to choose? We can measure the distance between the two nodes as the sum of distance to the closest common ancestor by putting in some weight. Like if they are in the same rack, then if they are in the same node, then the distance would be 0. If you read from the different node, but on the same rack, on the same data center, you can give it like a weight of 2. If you read it from different rack, you can give it to like the weight of 4. At the same data center entirely on different node, you can give it like the higher weight to denote that it has higher weight to read from. And then the system can decide on which computer it would read. It will choose the one that has the lowest score in terms of the distance. All right. Next, let's see how the HDFS write works. Right. Suppose the client want to write a file. The client need to connect to the name node and say that it want to write a file to the cluster. Then the name node would tell the client where to write the file. So it means that the client has to submit the size of data, and then the name node would report back on which node that the client should write the block to, and then the client would write the block directly to data node. And the replication factor that it has, then the data node would perform replication by itself, and then report back to the name node that everything is finished. Once one is failed, then name node would instruct the other one to make a copy, right? So if if that is the case, then HDFS need to put 3 replica on different blocks. So there are certain trade-offs to consider. Right? This trade-off includes the reliability of the cluster, the read and write bandwidth of the cluster. Strategy are like this. You can put all replica on one node, but if you put all replica on one node, the reliability would not be good, because if this node fails, then everything would be loose, right? But you would get good write bandwidth because you can just write it once. But well, not the case though. It might be true for a small file, but say if you have a large file and the network bandwidth is limited, this might not be the case. So I would say smile maybe less warmly than this one. But read bandwidth will not be good, because when you read a file from this one node, you need to kind of read it from the disk. It would not be parallel. If you put all replica in different node, then reliability will be high for sure, but write bandwidth will be low because you need to write to multiple computers, and also read bandwidth will be bad too. But why is it the case? Can you answer me? Put all replica on different rack. Why read bandwidth is bad? Just try to guess here. On different rack. The keyword is here. Because you will not put it on different node, but you are putting it on different rack entirely. Why is it bad for the read bandwidth? Why? You can remember earlier we said that you need to have 2 on the same rack and 1 on another rack. What will happen if you put everything on different rack entirely? What do you think would happen? Waiting for answer. Remember this? What happens if you put the package data onto different rack? Rack 1, rack 2, maybe rack 3. It takes much longer to read. Because of what? Because why do you think this big data is fast? Right? The reason that it is fast, because if you take a look at the way that you read and write, you can have client read and write the data from different nodes at the same time, right? You can read from different nodes at the same time. Suppose that DN1 is working from one client. If you store data on different nodes, it means that the client that come to read the data in DN1 has now to read the data file from another rack, which has higher cost in terms of bandwidth, right? But if you store the file, the block onto the same rack, but different node, it can read the data from that node rather than different rack. So that would make it more flexible, because if one node is busy, the client can read from another node, right? So that's the case here. If you store it different rack, then that would be a problem. But reliability will be high, because if it's, let's say, one rack is down, you still have 2 authors. That's quite high actually. So that's why there's this policy that when storing data in HDFS, one version will be stored in the same node as client, or let's say that the same node that is submitted inside, and another in the same rack, and the third one on a different rack. So you have high reliability because you store it in different rack, but read and write bandwidth would be kind of compromised between the two. Okay, so this is how you we summarize the way that you perform the operation with HDFS. HDFS will work closely with the framework like MapReduce. Now we'll talk about MapReduce next time. The HDFS is like the way that you store data. MapReduce work in similar way, but instead of focusing on the storage of data, MapReduce framework will focus on how can you distribute the function to run on multiple computers, to map the function and running on the different part of data on different computers, and then reduce them together. Right? Reduce means summarize them together. We will learn about MapReduce next time. It is the core concept of Hive, of the way that the database work on, I would say, Hive interface work on big data. Right. So next time you learn how to write MapReduce. MapReduce has something that is similar to HDFS. This is for the Hadoop one. It has, you need to assign the job tracker and the task tracker. The job tracker would split the data into the small tasks and then performing map, right? Sending it to the task tracker to process on each node. And then it would then transfer the data to perform reduce or summarization, or using something that related to using the result from map and then perform the task. Okay, so the task tracker, once it's done, would tell the job tracker that it is done. And then the job tracker would instruct to perform the reduce phase. So the concept here is actually can be implemented on different computers. If you take a look at Python, Python is already having something that is like MapReduce, but not specific to HDFS. So you can do the MapReduce style programming with other architecture as well. Right. So and there are many other software systems that work in distributed manner, like the GFS. And if you work with AWS, it might have its own distributed file system that you can work with. And but the idea would be similar to this one. So if you try to study different types of distributed processing, you can see that there are certain similarity between them. Okay. But the Hadoop here relies on HDFS, which we will see next time how it works. Hadoop has been used in different organizations in Thailand, abroad, and also in order to understand the way that this visualization and a lot of modern computing in enterprise work, Hadoop is like a stepping stone that allows you to grasp through the concept of visualization and maybe allow you to create a program that would work faster. It has been used in many companies. Right? So for example, Yahoo has a search web map, which run on the 10,000 core Linux cluster. Right? And Facebook has the Hadoop cluster of 100 of petabyte. I work with company like AAS and banks. They also have multiple Hadoop cluster. Each of them would be designed to do different tasks, right? Some of them will be designed to store data, but the other will be designed to use as the computing node. So they would have multiple cluster that work on different aspects of big data. When you have the system like that, it would, when it forms together, it would kind of form into a concept that when you store data in the distributed manner, the application that you run, instead of writing the program to work on the low level, you can write the high level code in Python and then instruct the system to do the task for you. But the idea that when you write a program, you need to write a program in such a way that the node need to communicate with one another as less as possible. So it means that if it can be run on the same node without having to communicate with another node, it would be better. But sometimes this is not the case. Sometimes you need the data from the other node to run as well, and it will make your program slower. But if you can share nothing, it means that if you can write a program, everything on just one node, it will make a program faster. And the data should be spread in advance. The community, like leaking the data during programming, during processing is not a good idea. Or transferring the data at the same time is not a good idea. You need to have like the data spread beforehand, and then you can map the program to run on those data. That is because if you take a look at the architecture here, you can see that the data block would be spread beforehand. And then if you want the client to process the data block, you want them to be separated. You want them to be independent. Then the client can run the program, tell the name node. Let's start, we can have something like a job tracker to distribute the job into different computer to run on the data that you want. And it will be much faster in that sense. And you can see the fault tolerance that if one node fails, the master will detect the failure and then reassign the task to different node. And it does not require communication with the node, right? Restarting the task does not require communication with the node working on the author portion, because you can just communicate with the node with that portion. And if it failed to restart, then you can assign to the new node to work on that. So this allows the system to be flexible in terms of management. When you learn about the workflow later on in this class, in the latter half of this term, you will learn about Airflow and UCI, which are the tools that you can use to manage the task. You see that a lot of aspects in workflow management is also similar to how this is done. That is, if the for the MapReduce program, if the program is down, that it can also restart and then run on the node that it has. It can also reassign to another node. Now let's take a look at the performance comparison. You can we can put it into a term of analogy, that is when we take a look at Hadoop. Hadoop would be an RDBMS like MariaDB, like the or Oracle. Comparing between the two, Hadoop would be more rough in terms of, and RDBMS will be more refined in terms of management right now. Back then, also in terms of, because back then when you work with Hadoop, you have to write the command line. Everything would be a little bit more difficult than RDBMS, which you can use the software to manage. Nowadays, still that case, although Hadoop has improved a lot. Now you have like high-speed train that are still a little bit rough in terms of deployment comparing to RDBMS, but it's still okay, right? It's already okay right now, easier to use. In terms of features, I would say that this is the 2012, the beginning of Hadoop 1.0, but right now they are quite comparable. On the contrary, I would say that Hadoop has a lot more features in terms of connecting and making things to run faster. While RDBMS has a lot of nice features that allow you to deploy and then connect to the local service as a server. So they work differently. It doesn't mean that if you have Hadoop, you don't need to have database. You can have Hadoop storing data, and you can have database RDBMS to store something that you require to just read on your local machine. Hadoop is slow to accelerate. It means that when you store data into Hadoop, you need to have a sizable file in order to make it, in order to see it different. While in RDBMS, you can kind of deploy and work it very fast. In terms of the price, Hadoop is a lot cheaper than RDBMS.
And Hadoop can carry almost anything, means that it can carry the file, you can store the file in, you can store things and make them the database, you can configure Hadoop as the data warehouse. But for the RDBMS, you need to just store data alone. Right? In terms of the size of the disk, this is more expensive comparing to Hadoop here. Because when we talk about enterprise level RDBMS, the data warehouse, this would be expensive than when you have the big data system Hadoop here. So that's how people think during Hadoop 1.0, right? Now today, I think things have moved toward that they are similar to a certain extent. Hadoop gives you more edge in storing large file. But if you want to store a small file, if you want to store a small size of data, update it a lot, you still want to use RDBMS, right? In my project, I use both. It depends on whether what do you want. Sometimes you want to store the text and metadata. You don't need Hadoop, you just need to have a database. But if you want to store, say, unstructured data in a large format, in a large size, let's say something like Wikipedia data, storing it in files is not efficient. If you want to query and you want to do other things, store it in Hadoop will allow you to get to the data quicker. That's in that way. But you need to have multiple computers to make it work. Now let's see the transit from Hadoop 1.0 to Hadoop 2, right? Hadoop 1.0 is like 2012 at the beginning, and people use that until say 2015, 5 years ago. Hadoop 1.0 has been thought of as it would revolutionize the field, but it turns out it flopped a bit because it is quite difficult to write a program in MapReduce. You'll see it next time, right? You need to think a lot on the strategy to write MapReduce. Comparing to Hadoop 2.0, Hadoop 2.0 contains this yarn, the cluster management, which you learn also after the midterm, right? Yarn acts as a kernel that performs resource management on how many RAM you can use, how much RAM you can use, how many core that you can assign to each executor to perform the task. And MapReduce and auto data processing will be plugged on top of Yarn, right? So beside having just two processing and storage, you now in Hadoop 2.0, you now have Yarn. So you can see Hadoop split data into blocks there. So it allows you to store data without or regardless of the native file size. You can store data in the big data, large data set. The idea should be something like write once, you write the data once, and then you read it many times so that it will be efficient. You can do the streaming data access, meaning that you can have the access to the data in a streaming way, right? By using tools like Spark Stream, then you can do the streaming. You can have you can use commodity hardware. Commodity means cheap. You can use hardware that is not something like require like high-end hardware. So this is unlike data warehouse that you usually need to have like a brand names hardware. Like you need to use Oracle, then you need to use hardware from Oracle for that, and they are quite expensive. Right? For this one, you can use like no-name PC in creating Hadoop cluster. It performs data replication. It has high throughput read and write, but you need to kind of doing the thing in the moving computation to the storage rather than moving data around, right? And the name will store the file system. So it works as a file system there. That's Hadoop. MapReduce, which you will learn next time, it contains two phases, the map and reduce. Think about this as a way to write a program, right? This way to write a program, you need to write a map function and a reduce function. A map function would perform mapping. It would go to your data and then compute. And reduce would take the result from the map and summarize. So the map would do the data operation in block. And then reduce would perform summarization of data from results from the block and then reduce it. to the result, right? Next time we will do this, right? But this time I will just explain what it is. Yarn, right? For the Hadoop 2.0, Yarn stand for yet another resource negotiator. So this will be the resource negotiator of the system. So it split the MapReduce and HDFS that is in Hadoop 1 into 2 pieces. That you have now resource management and applications. The resource management task is to manage resource. Application is to ask resource management to allow it to use the resource. So this is like operating system. It's like Linux kernel. And the user space that running applications, right? Your user space, the user application has to connect to the kernel so that the kernel can allocate the space for the software to use. So with Yarn, you can kind of run multiple programs in parallel, and it can also manage the usage of the resource. Good thing about Yarn is that it allows other software to also connect to Yarn. That means it doesn't have to take care of the lower level operating system stuff by itself. It now have a way to connect with the I/O to the system. Think about this like in not just in Linux, in Windows as well, right? When you write a program to connect to Windows OS, you usually call the OS to do the job for you. So this is the Yarn would work like that as well. And there are other components like beside this, right? Machine running HDFS would and multiple the set of machines, multiple machines that run this HDFS MapReduce would be known as the Hadoop cluster. And in the Hadoop cluster, there usually be some other software that we usually call them the ecosystems, right? Because there will be multiple software that do different tasks. Like we have Yarn, do resource negotiator. We have something like Impala and HBase and Flume and Scoop and Uzi and other type of software that do different things and that they are combined. You can see that if you are familiar with Linux operating systems, the way that all of these components works, the way that they are formed together or that we develop it, are really similar to the way that Linux has been developed. That in the Linux or in the Linux environment, you would have multiple people trying to contribute with different pieces of software, right? Here as well, right? Different software are developed for the framework, and then we the distributor like Cloudera, like what the other company back then there is MapR. I don't remember. Hortonwork, right? Cloudera, Hortonwork, MapR. Back then, they kind of package this and then add their own software and then distribute it as an enterprise software. Right now, the one that is survived the competition is Cloudera, which you probably use after the midterm, right? Why?
Yes.
Right. Okay. And so in the cluster, you can have like one node, like what we are doing in the lab, but you can also scale it out to be 1,000 nodes, right? The more node that you have, the better performance that the system can perform. So in the environment, you can have like multiple software, and they would have different cute logos. You have seen this Hadoop HDFS. This is elephant. There are like Flume that you will learn and Hive that Flume that you will learn after the midterm. Looks like logs, right? This is log. Log mean log data from the program, right? And this log in English means the tree log, right? Tree bark flowing to the water to the system. This is scoop, right? Look like scoop, right? Ice cream scoop. You can scoop it up from the database, the data, right? Hive, the bees, right? Beehive. Right? Why is the name like that? I don't know, but it works like the SQL, right? And there are others like this Spark. This is a star, right? Spark allow you to write program that is very fast, like star. Suppose should think about that. And solar, right? The icon is sol, right? Sun. Solar is actually the framework that you can create search engine. The fragmentation means indexing. So there are certain like icon names and whatever there, but there will be multiple software that you will learn in this course, not just in Python. Right? So you learn this time you will learn how to use the HDFS, Hadoop HDFS later on. So let's take a look. Each of these software would play a different part in the, I would call this the enterprise data analytic and processing framework. Right? So regardless of platform that we talk about, you can map them into different tasks. Like you require to have an infrastructure to store data. You need to have the data management that would manage how the data is stored. You need to have data integration that talk about how the data coming in, then the data processing that process the data that has been managed, right? You need to have application on top of data processing and the presentation on top of application that the client can access. On the right-hand side, you have the security management and the operation like the workflow management. So regardless of the software, whether this is, we talk about big data here, or whether we talk about like data warehouse back then, you can map them onto different parts here. Okay, for the big data, Hadoop big data system, it takes care of this part. For the infrastructure, it doesn't take care of this. But if you use AWS, if you use Azure or GCP, Google Cloud Platform, you also use the virtualization infrastructure from those services as well. And that service would also provide the other software there. But for the Hadoop open source, it would take care of the data storage, distributed data storage, the processing in distributed manner by using MapReduce. And it will have this HBase that would store data in a non-relational database. But there are other options that you can choose to store the non-relational database, the lower SQL database as well, besides having just HBase. There are now other HDFS compatible that can be used. And to access the memory on different computers at the same time, we have a framework like Spark that allows you to store data frame, right, that you use in Python on multiple computers at the same time, so that it accelerates the performance of the use of data frame. And in the data processing, you can do the batch using MapReduce or using software the SQL way like Hive or Pip. I don't think we will learn Pip though, because it's quite old. You probably learn how to use Hive and MapReduce. And Spark that this we taught later on. And the search engine, Solar, but probably not in this course though. If you're interested in this, I usually have the search engine course and text mining that taught in with but the search engines back then was used to taught. I used to taught it to teach it to the undergrad level, text mining for the master level. Now let's take a look at the integration. Integration contains the ingestion, meaning data coming in, Flume, Scoop, Kafka, right? Data coming out, you can do it by using Hive here. And other software that works similarly as well. On the outer layer, this depends on the type of software that you want to connect to data processing. For example, you can connect Tableau, which is a visualization software, to the data to this cluster through Hive, to Hive to Impala, right? So that you can create visualization from this big data system. You can connect, let's say, certain analytic app again to the cluster here. You can connect Excel to the big data. So there are multiple software that can connect to this type of way to this type of system. And then later in this course, you will learn different software, right? You will learn about HDFS, about Spark, about Yarn, for data storage, Spark MapReduce for processing, Yarn for management the workload internally. Workflow scheduling, you can use the Uzi to do the job. And there's a Zookeeper that is work for the coordination and, well, let's say the
protection of the cluster. Integration of data from outside can be done through Flume, Scoop, Kafka. I think you learn through Flume and Scoop. Kafka is a way that you can write message passing from a software, from a process to store that onto a computer. It's a little bit complicated to learn here. So you probably start with Flume and Scoop. And so this will be through software that you will learn, right? And then it will also contains different way of thinking that you have to think about. When you think about working with Hadoop, I want you to think about this picture. When I teach outside, I also draw this picture. You have a client. Usually, you need to connect this client to the cluster. And to connect to the cluster, you need to have one node to connect. We call this the edge node. Edge node. The node at the edge. And then inside, you have multiple computers connecting with one another, and the edge node will connect to them, right? So this is how it works. So that means when you work with Spark, when you work with other software, think about things as having different entities. Even though you work on your computer, right? When you work with your own computer, you are working as a client. That means when you upload the data to the cluster, even though the cluster is in your computer, but you are uploading it onto a different server. All right. So think about things as layers. It will allow you to understand the platform easier. Okay, the SQL engine that you can use is what does it mean by SQL engine? It means that if you run this process, you can have a server that work like MariaDB, work like MySQL, that you can MySQL that you can query the data out of the server. But this will be faster. You need to kind of define a way to read from the data of it. And author here, like the HBase that you will learn. And for Cloudera, you will have Hue as user interface to use all of these services. Okay. In working with big data, you need to choose the right component to perform the right solution. Like if you want to do the full text search, you need to use Solar. If you want to do the SQL engine, you need to use Impala. This is the code, the type of code. Impala is the software that allows you to create the types of SQL server that you can query the data. Interactive analytics means that it supports a smaller transaction. If you want to perform real-time processing, there is this Spark that allows you to write a program. Or if you want to store the data in the NoSQL format, then you can use HBase. Then putting them all together, we can have the data lake. Data lake is called like this because you have the data coming from different sources, and then you kind of put them all together as a lake. That's why it is called a data lake. Putting it in form of files, a file onto Hadoop, and then you can use the analytic tools, whether it's R, Python, or Tableau, or other software, to connect to Hadoop to perform the data analytics. Now, these are some examples on the connection of components that you can use to configure big data to do different tasks. Like if I want to create a data lake storage and connect the BI software to the data lake storage, I can have like data source coming into the system through the ingestion process. Ingest means eat, right? Ingestion mean importing the data onto a system. There are tools to allow you to do that, like Scoop and Flume, for example. And once doing that, you store data on HDFS and process the data. This can be done either use Spark, writing PySpark, for example, using Python to connect to Spark, or you can write MapReduce to perform MapReduce on the data.
Once the data is stored and processed here, you can connect this processed data, say CSV data that you already have processed, to the data service, like to the Impala, and then you can connect Tableau to Impala to create visualization that is very efficient. Usually, if you connect Tableau to the data of the size of, let's say, a couple of 100 megabytes, say 300 megabytes, it will be very slow for Tableau. But if you connect the Tableau to big data that store the data on that size, like 300 megabytes, it will be fast because the data processing query would be done very fast by the cluster rather than by the Tableau itself. Now for doing something like machine learning, right? Data warehouse can be used to pre-process and training data so you get the model. And then from that, once you have the transaction data coming in, you can use Spark streaming to stream the data and then predict with the machine learning. Once you get the results, you can export that result and then fetch to the campaign management and schedule SMS so that you can have like SMS service from the transaction data. If you want to use the system to perform analysis of the unstructured, you can use the system to gather the data, for example, from social network data, and then create your own program, maybe on the Spark, to analyze the sentiment and make prediction. And then you can use the BI tools or write your own web application to use the result from this service. And this is actually the old picture that your senior that now has started the startup company. They perform all of this in their fourth year to do the social network monitoring and then perform the analysis of the sentiment, analyze trend, and categorize text. Right? So this is done in the Hadoop architecture, big data architecture. And here's the last slide, which is about whether you want to use which to do to have the project success in the company. Choosing the right software is one of the things, but it might not be the key to the success. Sometimes the key is to realize that infrastructure need to be flexible. Like if you have the data that are stored across network, on-premise, then storing the data on-premise means in your own company. Then using Hadoop cluster might be a good way. Creating a cluster in your company might be a good way. But if the data analytics is performed on the new dataset, like the social network or the machine from the outside, then it is possible to do it on the cloud. And that would reduce the cost. Okay, and so lastly here is that you think about when you see where there is a word saying that the data is the new oils. Another thing is combustion engine. Big data is something like the thing that is allowing the two to work together. So it is the kind of the transmission and the other thing that allow you to utilize the data to the full extent. Right, and then the rest will be Hadoop file operation, which I will have explanation onto how to use the VM as well. So these are just example of commands. You can use it to, like Hadoop FSLS, to list the file, to read and show the file. But why we have different, you already have the different lab instruction. Let's take a look at that rather than this. This one would be like some reference that you can review later on. This is to create directory. You can see you just need to use command Hadoop fs, and then you can use the command just like in usual Linux command line to put the data from the local to the clusters, copy them, remove them, get them out. So these are examples of the command. We just type in the command and then it already performed the task. So it means that to use the Hadoop cluster by connecting it in this way, it's very easy. Right? It's a command line operation. Right? Okay, now let's take a look at your lab and also the environment that Y has set up. I'm going to allow the screen sharing in a moment. All right.
Okay, thank you. Okay, for my section is about instruct you how to use my VM that I have prepared for you. So this VM is the Fedora server, which is one distribution of Linux, which runs by the Red Hat organization. So I suppose you have downloaded and imported to your virtualization software. You can just, I will show you. So you just download all these files to your computer and then double click on the OVF files. Then the import wizard will guide you on how to import the virtual machine to your computer. Once you import, you can start the VM, and then the login screen will appear here. But we are not going to use this screen because it doesn't allow us to like copy and paste the command, which is quite, if you have a long chain of commands, it will like quite hard to like follow up. So what we're going to use is to use the web console, which Fedora provided us. So you can like note the IP address here. So I've got 192.168.184 and 162 and port 9090. So I go to my browser and then visit that address. This page will pop up. So you can log in here. So use the username and password is test user, just like in the slide that I provided you with the VM file here. So you can log in here, test user and test user. So once you log in, you can click the terminal here. And then you can use this terminal as in the usual Linux terminal. But it allows you to copy and paste. So it's very useful. Okay, I will scale it up a bit. Okay, for the basic Hadoop HDFS interaction, I will follow the slide that Ajahn Yai gave you. So first command is to list the files that in the system. For the Linux, we use ls, right? To list the file in the current directory. For the Hadoop, we do the same thing by specifying that we are gonna interact with the Hadoop file system using Hadoop S, and then followed by the same command that you use in the Linux file system, like ls here, to list the file in the current directory. So I have like this directory and two files here, one file and two directory. Sorry. So to read the file, you can use in the Linux, you can use head or cat or tail to read the part of the file. So in the HDFS, you do the same thing. If I want to read this file, I can just use cat to read the file and then followed by the file name here.
This is to read
yes.
your file and display and print them onto the standard output.
Yeah. So here, this command will print all the content of the file to the standard output. If you only want to read the head of the file, you can use head. Or just the tail of the file, the end of the file, you can just use tail. Right. To make a new directory, just like in the Linux, you can just use the Hadoop mkdir and followed by the directory name. So I will name it as new dir, and we list the file again. So here, my new directory that's newly created. To delete the file or directory, you can just use the rm like in the Linux. So to delete the file, you can -rm and then the file, which I will delete this file sherlock.txt. Okay, the file is deleted. To delete the directory, you have to specify the flag -r to identify that you are gonna delete the directory. So if you dealing with the directory, remember to add the flag -r. So I'm gonna remove my new directory. So I use Hadoop fs rm -r here, and the directory is removed. Here it's gone. To upload the file into the HDFS, you can use command Hadoop fs and put, and then file that you want to upload it into the HDFS. So in this case, I will just upload my, or let's navigate to my data folder. So I will upload this file to the HDFS. I can use Hadoop fs and put, and then followed by my file name here, and then just press enter. If we list the file again, here, my file is uploaded.
To understand this, you need to think about the picture that I draw earlier. That is the computer that you use right now. It contains two layers. It contains the local layers, and it also contains the, let's see, how do I annotate? Right. No, just staying and on that.
Okay.
Okay. So I'll use different color. Okay. It contains the local, which means the local Linux, and local Linux connect with the HDFS, right? HDFS. But think about this as cluster, although now it's just a standalone service. When you upload the file, you're actually putting it into the HDFS. Again, when you say list or authors, then it also work like that. All right, so move on.
Okay, for another command that you can use in the HDFS, like the Linux file system, is like move or copy. If I want to move this file to another folder, right? Let me create another folder here. So I will use the command here again. And I want to move these files into my newly created folder, new dir here. What I'm going to do is I can just use Hadoop fs mv, and then the source. So my source is superstore order, and then destination is my new dir. And if we list the files again, you see that the superstore order is now gone. It's inside the new dir. If we list the file that inside the new dir, you will find the superstore order is here. So this move command to copy is the same way. You just change the MV to CP. CP is for copy. And again, if you're working with the directory, do not forget to add the flag -R here. If you are dealing with the directory. Okay, for the last command that I'm gonna demonstrate to you is how to download the file from the HDFS to the local file systems. You can just use the Hadoop get and then the path to the file that you want to download. So I'm gonna copy it here and paste it here. So before I'm gonna run this command. So here on my local file systems, there's no superstore.csv, right? But when I run this command, it's just like that you download the file from the HDFS to your local file system. So yeah, superstore.csv is here. So this is the basic interaction that you can do with the Hadoop file systems.
Okay, thank you, Wai. One thing to be careful though. One thing to be careful. Why could you do the list file on Hadoop with the slash with the root? Right. Be careful about the symbol here. Slash means the root, but your current directory that you use in Hadoop would be the user directory, not the slash directory. So when you copy the code either from internet or from the authors, be careful about the directory location. This is often the mistake that I find. That is, if you are not aware that in the Linux file system, when you use slash, it means that you are going to the root location of the storage, and you can see that the root location it has two folders like TMP and users. Actually, the test user, the one that we use here, you can use slash user, right? It's a subdirectory of the user, because there will be other users that are also using this service as well. Like the user can be a program like Hive and other things, right? So be careful about the location, right? All right, now the lab.
Actually, there is no lab for this week.
Okay, now, so I'll give you one here. Play around with this, right? So there's nothing to submit, but try to be familiar with this tool, because next time you have to use this to do the map reduce, okay? Play around with it, play around with not just the Hadoop alone, try to be familiar with Linux, because we will use it throughout the semester. Okay, and you probably love it after this course, maybe. You will switch everything from Windows to use Linux. If I did that back then, once upon a time, but now when I work with authors like this, I have to use Microsoft Word. That's why I still need to have this, using this. Okay, all right. In any case, try for your assignment this week, try to play around. Nothing to submit, but I hope that next time you gain a lot more knowledge and be familiar with the HDFS and how to interact with the system. Any questions? No? All right, I remember. Usually we have lab for this class because we would ask students to install their own, right?
Yes.
To install their own HDFS, their own Hadoop. But this time we decided to use VM, so that's why we don't have it here. No mind. Okay, if nothing, if there's no question, let's end the session here, right? So see you next week. Next week will be the last week before. Okay, maybe you may want to talk about the midterm exam. Next week will be the last week. We will learn about MapReduce, and afterward will be midterm exam. Right, the midterm exam contains every topics before the midterms. Right, it will be you will have about 40 questions, 40 questions, multiple choice and matching, yeah, when it comes to matching on the class marker. I will post the link so it will be just like in data models that you have tried before. That is, you can use your ID to log into the system, right? And that's it, I think. And then do the exam. And if you have problem during the sign in and whatever, you can contact me. I have the ability to kind of reinitialize the part of the exam just for you there. Okay. Any question that you like to ask? Well, if not, then let's see each other next time. Right? Next time we will learn about MapReduce. Okay. Bye, everyone.